You can eat a sensible dinner, take your supplements, fall asleep at a reasonable hour, and wake up feeling perfectly fine, while your body's overnight repair system has been running at somewhere around 30% of its actual capacity. Not because anything is wrong on your blood work, not because your doctor flagged anything, because three specific foods that serve as the raw materials for that system were missing, and no one in a 12-minute clinical appointment has time to explain why that matters. Most people think sleep is the time the body rests. That framing is wrong in a way that has real consequences after 60. Sleep is the time the body builds every pulse of growth hormone your body releases, and after 60, those pulses are already roughly half the amplitude they were at 30, happens in the dark, in the deep stages of sleep, during windows that open and close on a precise biological schedule. Those pulses require raw materials. Without the right inputs delivered at the right time, the night shift construction crew shows up, finds an empty warehouse, and goes home. Nothing gets rebuilt. You wake up feeling fine. The deficit accumulates silently. By the end of this, I'm going to give you a three-part food strategy I call the overnight rebuild window. Three specific foods, specific timing, and one variable that most people get wrong every single night that invalidates the entire system even if everything else is correct. You can start tonight. But first, I need to introduce the invisible villain. Because this is not a story about three superfoods you've never heard of. It's a story about why everything you're already doing works against you if you don't understand one hormone relationship. The villain is insulin, specifically evening insulin. When you eat anything at all, your pancreas releases insulin to manage the glucose entering your bloodstream. That is the system working correctly. The problem is what insulin does to another hormone, human growth hormone. These two compounds operate in direct opposition. When insulin is elevated, growth hormone is suppressed, not slightly reduced, suppressed. A study published in the journal Diabetes in 1988 documented this mechanism at the pituitary level, the small gland at the base of your brain that coordinates the entire hormonal repair cascade. The researchers found that even a modest insulin elevation was sufficient to inhibit growth hormone secretion directly at the source. Think of growth hormone as the foreman of the night shift crew. Every time you eat refined carbohydrates, sugar, a glass of juice, or even crackers in the 3 hours before bed, you are locking the foreman out of the building. The crew might still show up, but without the foreman, nobody knows which tissue needs priority, how much material to allocate, or in what sequence to work. The shift runs, very little gets done. You wake up having technically slept 8 hours, and your body is functionally less repaired than it should be. A study published in the Journal of Clinical Endocrinology and Metabolism found that an insulin elevation of roughly 30 micronewts per milliliter, the kind you'd see after eating a single piece of toast, was sufficient to reduce growth hormone secretion by approximately 50%, half, from one piece of toast eaten at 9 p.m. This is not a niche concern confined to athletes or bodybuilders. Sarcopenia, the gradual involuntary loss of muscle tissue that accelerates after 50, proceeds at a rate of 1 to 2% of total muscle mass per year in most adults over 60. By 65, the average person has lost enough functional muscle to meaningfully alter their balance, their resting metabolic rate, their bone density maintenance, and their cardiovascular efficiency. Research published in the American Journal of Clinical Nutrition identifies low skeletal muscle mass as one of the strongest independent predictors of all-cause mortality in older adults. That is the clinical phrase for dying from any cause, not from a specific disease, from everything. So when I tell you that three foods eaten at the right time can meaningfully support the repair systems that run during sleep, I want you to hold that context. This is not about feeling slightly less tired in the morning. This is about whether the body you are living in at 70 reflects the maintenance work you did at 60, or whether you defaulted into the trajectory most people accept because no one explained the mechanism. Let's start with number 3. The third most impactful food for overnight repair after 60 is tart cherry, not sweet cherry, not cherry-flavored products, not a cherry blend. Tart cherry, the Montmorency variety specifically, which is sour, small, and red, and has been used in most of the peer-reviewed research on this topic. Here is what most people believe when they take a melatonin supplement. Melatonin makes them drowsy, they fall asleep faster, and sleep improves. That part is roughly accurate. What almost no one outside a sleep research lab knows is that melatonin is simultaneously one of the most potent antioxidants the human body produces. During sleep, it directly neutralizes free radicals, broken molecular fragments that accumulate in tissues during waking hours and damage cellular structures on contact, in a process that operates in parallel with the sleep cycle itself. Think of it as a two-job employee. One job is to trigger sleep onset, the other is to patrol the cellular neighborhood and clean up damage. After 60, your natural antioxidant enzyme systems become less efficient, and the ratio of oxidative damage to repair capacity shifts unfavorably. The result is a condition researchers call oxidative stress, which you can visualize as rust accumulating inside your cells faster than the polishing crew can remove it. Tart cherries contain actual melatonin, not a precursor. The finished molecule, identical to what your pineal gland manufactures. A study published in the European Journal of Nutrition in 2010, led by Howatson and colleagues at Northumbria University, found that participants consuming tart cherry juice showed measurably elevated circulating melatonin levels, with sleep duration increasing by an average of 84 minutes compared to the placebo group. Sleep quality scores also improved significantly on validated questionnaires. But the mechanism goes deeper than melatonin. Tart cherries contain high concentrations of anthocyanins, the pigments responsible for their deep red color, which suppress an enzyme called cyclooxygenase 2, or COX-2. This is the same enzyme that ibuprofen inhibits. COX-2 drives inflammatory cascades throughout the body. After 60, a process researchers now specifically call inflammaging, inflammation as a component of the aging process itself, runs as a constant background condition in most adults. It operates below the threshold of symptoms. You don't feel it as pain. It manifests as gradual degradation of joint cartilage, arterial wall stiffness, slower wound repair, and measurable changes in cognitive function over time. A 2004 study published in the Journal of Nutrition found that tart cherry consumption was associated with significantly reduced circulating levels of C-reactive protein and uric acid, two established blood markers of systemic inflammation. C-reactive protein is produced by the liver in response to inflammatory signals elsewhere in the body. It doesn't cause damage directly, it is a measurement of damage happening elsewhere. Elevated C-reactive protein in older adults predicts cardiovascular events, accelerated cognitive decline, and worsening metabolic function. Reducing it through food is not a minor lifestyle intervention, it is modifying a downstream consequence of the core aging mechanism. One more tart cherry mechanism that receives almost no attention in popular nutrition writing. Tart cherries contain tryptophan, the amino acid that serves as the starting material for serotonin synthesis. Your body converts tryptophan to serotonin and serotonin to melatonin in a two-step enzymatic reaction. So tart cherries are delivering both the precursor and the finished product simultaneously, the equivalent of a supplier arriving at the warehouse with both the raw steel and the finished frame. The body doesn't have to synthesize the entire chain under suboptimal nighttime conditions. Much of the work is already done. The practical delivery: 8 ounces of unsweetened tart cherry juice, not a blend, not a cocktail, not cherry-flavored water, or 1 cup of fresh or frozen tart cherries, consumed 60 to 90 minutes before your target sleep time. The timing isn't approximate. Melatonin synthesis is circadian. It follows the light-dark clock, and introducing it too early can shift your internal rhythm rather than reinforce it. 60 to 90 minutes is the window the research points to consistently. That's number 3. Now let's move to number 2, which is where I want to explain something the mainstream nutrition world has been getting demonstrably wrong, not through malice, but through a combination of lazy extrapolation and the slow pace at which clinical research corrects popular belief. We have been told for decades that eating before bed causes weight gain. Finish dinner by 6, don't snack after 8. Anything consumed at night gets stored as fat. I heard this growing up. My husband heard this. His first cardiologist repeated it during the period when we were trying to understand what had happened to his health and what we could actually do about it beyond the medication stack he'd been handed. It is presented as established wisdom. The research published in the last decade and a half tells a substantially different story. A series of studies from Maastricht University in the Netherlands, led by researcher Luc van Loon and his team, examined what happens specifically when older adults consume protein before sleep. The mechanism they were tracking is called muscle protein synthesis, the biological process of constructing and repairing muscle fibers. The key study, published in the Journal of Nutrition in 2017, gave participants 40 grams of casein protein 30 minutes before sleep and measured muscle protein synthesis markers throughout the overnight period. The result, significantly elevated protein synthesis throughout the night compared to the control group that consumed nothing. The protein was absorbed, the muscles were being built, not despite the pre-sleep consumption, because of it. Casein, the primary protein in Greek yogurt, cottage cheese, and milk, behaves differently from other proteins in a way that is directly relevant to this mechanism. When casein contacts stomach acid, it forms a gel. It doesn't flow through, it clots and dissolves slowly, releasing amino acids into the bloodstream at a steady rate over 4 to 7 hours. This is a timed release delivery system built into the protein's molecular structure. While you sleep, your muscles are receiving a continuous supply of the amino acid building blocks they need for repair, rather than a single pulse that processes and clears before the repair window closes. Compare this to whey protein, which is commonly associated with muscle building and fitness culture. Whey is rapidly absorbed. The amino acid spike peaks within 60 to 90 minutes and is largely cleared from the bloodstream within 2 hours. For post-workout recovery, when rapid delivery matters, that speed is useful. For overnight repair, when the work happens over 6 to 8 hours of slow-wave sleep, that speed is a mismatch. You want irrigation, not a flash flood. After 60, this mismatch has consequences that compound over time because of a phenomenon called anabolic resistance. Younger muscle tissue responds to a small amino acid signal with vigorous protein synthesis. Older muscle tissue has become less sensitive to that signal. It requires a higher threshold of amino acid availability to trigger the same repair response. Think of it as a sensor that needs a stronger input to activate the same output. This is one reason the current recommended dietary allowance for protein, 0.8 grams per kilogram of body weight per day, is increasingly viewed in clinical nutrition research as inadequate for adults over 65. A position paper from the European Society for Clinical Nutrition and Metabolism, which reviewed evidence from multiple large studies, suggested that 1.2 to 1.6 grams per kilogram per day is a more appropriate target for older adults looking to preserve and build muscle mass. The standard recommendation was set based on nitrogen balance data in younger adults. It was never designed for the aging muscle environment. Greek yogurt is the practical delivery vehicle for several reasons simultaneously. A typical 6-ounce serving of full-fat Greek yogurt contains 17 to 20 grams of protein, the majority of which is casein. It contains live probiotic cultures, Lactobacillus and Bifidobacterium strains, that support the gut lining's integrity during the overnight fasting period. It provides calcium and phosphorus in forms that are bioavailable for bone remodeling, which is the process of dissolving and rebuilding bone tissue that runs primarily during the same overnight window as muscle repair. And the fat content in full-fat varieties slows gastric emptying, which extends the amino acid release window slightly beyond what the casein achieves on its own. Every element of the full-fat Greek yogurt format serves the overnight repair mechanism. On bone remodeling specifically, because this deserves more attention than it typically gets in nutrition conversations focused on muscle, your skeleton is not static. It is constantly being torn down by cells called osteoclasts and rebuilt by cells called osteoblasts. In youth, osteoblast activity outpaces osteoclast activity, and bones grow denser. After menopause in women, and more gradually in older men, the balance shifts. Osteoclast activity begins outpacing osteoblast activity, producing net bone loss. The calcium in Greek yogurt is a direct material input to osteoblast function. You are handing the construction crew bricks at precisely the time of night when the construction is scheduled to happen. The recommended amount for the overnight repair window, between 20 and 40 grams of casein, consumed 30 to 60 minutes before sleep. One 6-ounce serving of Greek yogurt gets you to approximately the lower end of that range. 2 servings, or a combination of Greek yogurt and cottage cheese, puts you closer to the 40-gram ceiling without generating an insulin response large enough to meaningfully disrupt growth hormone release. This is the balance the protocol is designed around. Now, number 1. I want to be straightforward about my reaction when I first encountered this data because I think it illustrates something important about how we habitually underestimate familiar foods. The food is kiwi, the ordinary, inexpensive, bright green kiwi fruit available in every grocery store in the country, which most people consider a pleasant source of vitamin C and nothing more. Researchers at Taipei Medical University in Taiwan published a study in the Asia-Pacific Journal of Clinical Nutrition in 2011 that examined what happened when adults ate 2 kiwi fruits 1 hour before bedtime every night for 4 weeks. At the end of the study period, participants fell asleep 42% faster, slept 13% longer, and showed a 35% reduction in what researchers call wake after sleep onset, the technical measure of time spent lying awake after initially falling asleep. That last metric matters specifically for adults over 60, because fragmented sleep, waking multiple times throughout the night, is one of the most common age-related sleep changes, and it is the fragmentation that disrupts the repair architecture, not simply the total hours. The study population was younger than the audience I'm speaking to, adults between 20 and 55, which is a limitation worth acknowledging. But the mechanisms responsible for the outcomes are more relevant in older adults than in younger ones, because the deficits the mechanisms address are larger after 60. Let me explain what I mean. Kiwi contains serotonin in meaningful concentrations. Not a serotonin precursor, actual serotonin, the same neurotransmitter produced in the gut and brain. Roughly 90 to 95% of your body's serotonin is produced and stored in the gut, not the brain. The gut's serotonin system communicates with the central nervous system through the vagus nerve, a direct highway between the intestinal nervous system and the brain, and regulates sleep architecture, mood, and pain sensitivity. When peripheral serotonin levels are adequate, the enzymatic conversion to melatonin is more efficient, and the resulting sleep shows deeper slow-wave stages. Slow-wave sleep is where the most important repair work happens. It is during slow-wave sleep that the largest growth hormone pulse of the 24-hour cycle is released, typically within the first 90 minutes of sleep onset, accounting for 50 to 70% of total daily growth hormone output. It is during slow-wave sleep that the body prioritizes protein synthesis in skeletal muscle. And it is during slow-wave sleep that the brain's glymphatic system, the specialized waste clearance mechanism that uses cerebrospinal fluid to flush metabolic debris from neural tissue, operates at peak efficiency. That glymphatic mechanism is worth describing in more detail because it is one of the most significant neuroscience discoveries of the last 15 years, and it remains almost entirely absent from popular health content. Your brain generates metabolic waste products continuously during waking hours, including a protein fragment called beta amyloid and another called tau, both of which in excess are associated with neurodegenerative disease pathology. The brain cannot flush this waste while it's running at full cognitive capacity during the day. During slow-wave sleep, neurons actually contract slightly, widening the spaces between them, and cerebrospinal fluid flows through those expanded channels in pulsed waves, clearing the debris mechanically. Think of it as the difference between cleaning a crowded room while people are still working in it versus clearing the space after everyone leaves and doing a thorough sweep. Oxidative stress disrupts this process. When free radical activity is high in neural tissue, the cerebrospinal fluid flow becomes less efficient and clearance is incomplete. The antioxidants in kiwi, notably vitamin C at roughly double the daily recommended intake per 2-fruit serving, plus vitamin E and a range of polyphenolic compounds, reduce oxidative stress in neural tissue specifically, improving the conditions for glymphatic clearance. A cleaner brain is not metaphorical. The debris removal has measurable consequences for cognitive performance, emotional regulation, and long-term neurological health. The folate content of kiwi adds a separate layer to this picture. Kiwi is one of the most bioavailable dietary sources of folate, vitamin B9, available in whole food form. Multiple studies, including research published in the Journal of Psychiatric Research, have found correlations between folate status and sleep quality, specifically pointing to reductions in slow-wave sleep duration in folate-deficient adults. Folate is a central player in what biochemists call the methylation cycle, a set of reactions that regulate gene expression, neurotransmitter production, and the repair of DNA damage that accumulates during waking hours. Think of methylation as the overnight editorial team that proofreads the body's instruction manuals. Folate deficiency leaves that team short-staffed. The proofreading happens more slowly, errors accumulate, and the cellular instructions for repair become progressively noisier. 2 kiwi fruits. 1 hour before sleep. Whole fruit, not juice. The fiber matrix matters for moderating glucose release and for gut transit. Some research suggests the skin contains higher concentrations of polyphenols than the flesh, though eating it is a personal choice rather than a requirement. Now I want to bring the invisible villain back in because here is where the three foods either work or fail based on one variable that undermines every other correct choice. I described earlier how the largest growth hormone pulse of the day opens approximately 90 minutes after sleep onset. What I want to add is that this window does not wait. It does not reschedule. If your insulin is still elevated when that window opens because you ate something starchy or sugary 2 hours ago, the pulse is blunted, not postponed to a later sleep stage. Blunted at that amplitude for that night. The construction foreman was locked out during the only shift he was scheduled to work. The three foods in this protocol are specifically selected because they are repair inputs that do not generate the insulin elevation that triggers this suppression. Tart cherries have a lower glycemic impact than most fruits because their anthocyanin content slows carbohydrate absorption in the small intestine. Greek yogurt's fat and protein combination produces a slow, modest insulin response that peaks and clears well within 2 hours when consumed appropriately before sleep. Kiwi, despite its sweet taste, has a glycemic index of approximately 52, moderated by its fiber content, and does not generate a sharp insulin spike in most metabolically healthy adults. These foods deliver building materials through the door without triggering the alarm. And here, before I give you the full protocol, I want to say something that has been sitting in the back of everything I've described. I had read all of this. I had the tart cherry juice in my refrigerator. I understood the casein timing mechanism because I had printed out Van Loon's Maastricht studies and read them during a period when I was trying to understand what had gone wrong with my husband's health and what we could actually build forward from. And it still took me longer than it should have to make any of it consistent because reading the mechanism and building a daily habit out of it are completely different cognitive tasks. The gap between those two things is where most people quietly give up. My husband thinks in systems. He eventually took everything I've described, the timing windows, the food combinations, the phase-by-phase adaptation, and structured it into a 30-day daily companion he called the Noon Reset Protocol. 2 pages per day. 1 page explaining the relevant biology for that day in the same plain language I use here, 1 page for tracking. He built it around 4 phases: adaptation, activation, optimization, and acceleration, because the way your body responds in week 1 is physiologically distinct from week 4, and applying week 4 expectations in week 1 is precisely why most people quit around day 4 or 5. He included 25 breakfast meal ideas with exact protein counts, because the question I get most often isn't what to eat before bed, it's what to eat when you break the fast at noon without undoing the overnight repair the body just ran. That answer requires context. He mapped it out. It's available through the link in the description for less than a restaurant meal. I resisted using the structured format for months because I thought I knew enough to improvise. I didn't. The structure is what made it consistent, and consistency is the only variable that matters biologically. Now I want to add one more layer before the protocol itself, because there is a gut mechanism connecting all 3 of these foods that almost nothing in popular nutrition writing addresses, and it directly affects how efficiently the overnight repair system runs. Your intestinal lining, the layer of epithelial cells on the inside of your small and large intestines, is replaced entirely every 3 to 5 days. This makes it one of the most rapidly replicating tissue systems in your body. The cellular energy for that replication is primarily supplied by a compound called butyrate, which is a short-chain fatty acid produced by specific strains of gut bacteria when they ferment dietary fiber. Without adequate butyrate production, the intestinal lining develops increased permeability, a condition the research literature describes in careful technical terms, though you may have encountered it under the popular label of leaky gut. What it means practically is that bacterial fragments called lipopolysaccharides can cross the gut wall into the bloodstream, triggering a systemic immune response and amplifying the exact inflammaging process that degrades joint tissue, arterial walls, and neural health over time. The probiotic cultures in Greek yogurt, particularly Lactobacillus and Bifidobacterium strains, are among the bacterial species that support butyrate production. Consuming them before the overnight fast means they are active in your gut throughout the repair window, supporting the lining renewal process while your immune system is doing its overnight calibration work. The slow digesting casein keeps the gut environment fed and stable rather than leaving it empty and acidic for 8 hours. Kiwi adds a specific and underappreciated enzyme to this picture: actinidin. Actinidin is a protease found in high concentrations almost exclusively in kiwi fruit. It is one of the distinguishing molecular features of the fruit. Research from the Ridet Institute in New Zealand found that actinidin can improve gastric protein digestion efficiency by up to 40% for certain protein sources, including dairy proteins. What that means in practical terms is that the protein you consume in your Greek yogurt is digested and converted to amino acids more completely when kiwi is also present. More of the protein reaches your muscles, less is excreted. The synergy is not incidental. It is an enzyme pathway that exists because these nutrient sources work better in combination than in isolation. This is the structural logic of eating tart cherries, then kiwi, then Greek yogurt in a 60 to 90-minute window before sleep. Each element does something specific. Each element also improves the function of the others. Here is the overnight rebuild window. All 3 components named and sequenced. The first component is the anchor. 60 to 90 minutes before your target sleep time, eat 1 to 2 kiwi fruits. This initiates the serotonin to melatonin conversion pathway, delivers the antioxidant preparation for glymphatic clearance, and activates the actinidin enzyme that will improve protein digestion in the next phase. The common mistake with the anchor is timing. Eating the kiwi immediately before bed does not give the serotonin conversion pathway adequate time to complete. The 60 to 90-minute window is based on the documented enzymatic conversion rate, not on approximation. The second component is the foundation. 30 to 45 minutes before sleep, consume between 20 and 40 grams of casein protein, ideally through full-fat Greek yogurt, cottage cheese, or a combination of both. The actinidin you introduced 20 to 30 minutes earlier with the kiwi is now active in your stomach. The casein you add now will be digested more completely than it would have been without that enzymatic priming. The slow-release amino acid supply will be available to your muscles and bones throughout the slow-wave sleep cycle. The critical error that invalidates the foundation, pairing it with any simple carbohydrate, honey, granola, fruit added for sweetness, all of these produce insulin elevation. The insulin locks the foreman out. The crew runs the shift without direction. Eat the protein plain. The third component is the signal. Within the same 30 to 45-minute window as the foundation, consume 8 ounces of unsweetened tart cherry juice or 1 cup of tart cherries alongside the Greek yogurt. The anthocyanins reduce circulating COX-2 inflammatory activity, clearing the biochemical environment for repair. The melatonin in the tart cherry amplifies the melatonin conversion the kiwi initiated 30 minutes earlier, but because the mechanisms are different, they are additive rather than redundant. The kiwi worked upstream in the serotonin conversion pathway. The tart cherry delivers the finished melatonin directly. Together, they produce a more sustained melatonin signal than either food alone, supporting longer and deeper slow-wave sleep architecture. The single mistake that invalidates the entire protocol, regardless of how perfectly the three components are executed: consuming refined carbohydrates, sugary beverages, or alcohol within 2 hours of sleep. Not because these things are categorically forbidden at other times of day, because the insulin they generate during that specific pre sleep window is the mechanism that suppresses the growth hormone pulse that drives everything the overnight rebuild window is designed to support. The three foods do not fight elevated insulin, they simply operate in the window that low insulin leaves available. If you narrow that window with crackers and juice, you have done the equivalent of scheduling the construction crew to arrive after the building is already closed. There is a psychological reality underneath all of this that I want to name plainly because I think it explains most of the gap between people who understand this information and people who actually use it. The hours between 8 and 10 p.m. are for most adults the period of highest decision fatigue in the day. Cognitive resources are depleted. Willpower, to the extent that is even a useful concept in neuroscience, and the research suggests it isn't as useful as the diet industry needs it to be, is at its lowest. This is also the precise window that the packaged food industry has historically optimized its products for. Late night snack formats, chips, crackers, cookies, flavored beverages, are engineered using decades of behavioral psychology research to maximize consumption in exactly this low resistance window. The palatability engineering, the portion size calibration, the package design, the shelf placement in grocery stores, all of it is downstream of the same fundamental insight. Exhausted people make different decisions than rested people, and that difference is profitable. Understanding this is not paranoia. It is reading the industry's own documentation back to them. The gap between knowing what to eat before bed and actually eating it is not primarily a knowledge gap. It is an environment gap combined with a decision fatigue gap, and the food environment has been deliberately shaped to exploit both of them. The overnight rebuild window works because it replaces an open-ended decision with a closed sequence. You're not choosing between kiwi and crackers at 9 p.m. when your prefrontal cortex is already half offline. You're executing a pre-committed sequence. The decision was made earlier when your cognition was intact. This is also why the structure my husband built into his protocol mattered more than I expected it to. The 2-page per day format removes the nightly decision entirely. The sequencing is pre-built. The adaptation phase accounts for the fact that your gut microbiome takes 10 to 14 days to meaningfully shift in response to new probiotic inputs, so the first week is not supposed to feel dramatic. Expecting dramatic results in week 1 and not getting them is why most people quit in week 1. The structure accounts for that. The structure is why it works consistently rather than intermittently. If you are going to start the overnight rebuild window this week, the kiwi 60 to 90 minutes out, the Greek yogurt and tart cherry in the 30 to 45-minute window before sleep, and nothing refined in the 2 hours before the window opens, comment night shift below so I can see who is actually implementing this. And if this channel gives you the kind of information you find useful, mechanisms, not motivation, sources, not sound bites, subscribe, because that is everything this channel is built to